So this is an introduction to the VC SLEW module for the hale modular system that I've been designing. It's going to be kind of a quick start introduction. I'm going to try to do some more in-depth videos later when I've got better video equipment here. For now, there's a couple of these out there, and I've been getting some questions about how everything interacts, so hopefully this will answer those questions and get you started using it. So the VC SLEW is a dual module. There's two sides. They're basically identical. They only really differ in how the two sides are treated by the center comparing jacks here, which I'll get to shortly. You've got an output at the top, which is going to be a slewed or sampled version of whatever's going into the input. You have a cycle jack. So the cycle output is always going to be +5 or -5 volt. It's an inverting Schmidt trigger that monitors the output, and when the output passes +2.5, the cycle drops to -5. When the output passes -2.5, the cycle pops back up to +5 volt. It's intuitive. Once you've worked with it for a little bit and you've played with it, it's intuitive. Basically, this is a triangle core oscillator that you have to make the final connection. So if you want this to self-oscillate and be a triangle oscillator, you take a shorting bar or a banana cable and you plug input into cycle, and it will self-cycle, and you'll have control over the rate. You have a voltage control input here with an attenuverter, and you have a 1 volt per octave control. In the audio range, you'll get 4 or 5 octaves of good tracking out of this. It is a very wide range module. It goes very slow, very fast. And related to that, you will have some high frequency tracking errors at the top end of the audio rate it's capable of, and that's just part of the compromises that had to be made to get the widest range possible out of this thing. That cycle jack is one of the new outputs. I used the orange cycle is an orange jack. The greater than comparator here is an orange jack, and I've actually got another orange jack over here on this little comparator module over here. So the orange jacks are a new output. They are logic compatible. You can plug them into logic ins, and they do give logic info like on or off. The difference is on is +5 volt and off is -5 volt. So it not only gives on-off information, it also gives polarity or sign information, which is important to me for comparator output, and it's also important for some of the patches that you can do with this, one of which I will definitely show at the end of this video. The input, already mentioned that. The hold jacks here, that's a dual function jack, and what it does will depend on the mode. Now these buttons here are the mode selection buttons. Each side can be either sample mode or SLEW mode. LED on means that it is in sample mode. When it is in SLEW mode, a logic high into the hold jack will freeze the output. So if we want to listen to an audio example of that, if I use the output here, this triangle output, to modulate a VCO, and we plug this into the hold jack, it's going to freeze it whenever that goes high. In sample mode, a logic high into the hold jack will sample, and it's a rising edge detector, so it will sample on the rising edge of a logic trigger coming in. So same patch, we haven't changed anything, we've just changed the mode, and we can listen to the difference. And this is how you'd make kind of your classic stepped triangle type sound if we turn this rate up and turn this rate up. There you go. Now the center jacks are two different types of comparators. We have a greater than comparator, which is also one of those special orange logic output jacks. That is a comparator that is, when the left side is greater than the right side, that will be high. When it is lesser than, it will be low. the timing output is a logic signal 0 to 5 volt. It's a quick pulse like a trigger, and you will get a trigger out of this every time the greater than comparator changes state. Another way to think about it is you will get a trigger here every time either side crosses the other, either going up, going down, doesn't matter. So to listen to an example of that, we can get this side self-cycling, and we're going to get an LED firing from the timing gate here. Now, because it's comparing against this side, which is at 0 volt right now, we're going to get just a totally regular trigger of the envelope here. There we go. But if we now self-cycle the right side, those two triggers will get closer and further apart from each other. It's a great way to get some like funky, crazy rhythms going, and it's useful for other patches too. One of the things it's critical for is the random voltage generation patch, and it uses both the special logic that I've been talking about, uses this timing jack, and it also uses this jack, which is the only one I haven't mentioned yet. Sample and hold source is a noisy, modulated saw with a lot of like white noise and other stuff mixed in, and it's the ideal random voltage source to be sampled by this style of sample and hold. So the random voltage generator patch, what it is you will get voltages that are random in terms of amplitude and also random in terms of how much time in between the next new sample. So the patch setup is sample and hold source into input, left side sample mode, timing plugged into the hold jack of the left side, and then the greater than comparator plugged into the input of the right side. And now, if we want to listen to what this sounds like, and I will send the stepped voltage to control this oscillator. You can slow it down with this. Add a little bit of delay. And I will kind of just wander around and acquire new voltages, and sometimes be slower, sometimes be faster. This will control the rate, and this will control how far apart the new voltages are allowed to be. And out of the left side, you'll get stepped voltages like we've been listening to, and on the right side, you will get, just open that wide open. Out of the right side, you will get the slewed version of those random samples. So another thing that I've been asked is whether, in sample mode, whether it's accurate, whether you can sample 1 volt per octave signals with this and use it with melodic work. And the answer is yes, with kind of one complication. So the setup for this is I'm going to control, I'm going to add a second oscillator to what we've been listening to. I'm controlling the first one with this sequencer output right here. The second VCO is going to be controlled by this CV path going through this side of the VC SLEW. And we're going to use it in sample mode, and I'm going to use this side as the oscillator to trigger it. So I got to plug that into the hold jack to sample new voltages. So the complication is when it's in sample mode, the rate control controls how big of a jump it can make. So once it gets to the voltage it's supposed to be at, it's accurate and it will hold it, but this will control how many jumps it's going to take. So if I put that all the way up, biggest jump possible, and if I turn this up, and if I turn up my second oscillator here, you can hear they're basically phase locked. Hopefully you can hear that. I'll just make sure they're locked here. There we go. So that's not these are at max, it just stays phase locked. But if I turn this clock down, and if I turn the size of the step down, you get those kind of effects. And you can abuse that. Like if you run that signal through a quantizer, obviously you're going to get like scales as it approaches the right note, and you're going to get fun stuff like that. You can also use it to save just a certain step out of a sequence, and just save a certain step. I'll probably have to do some further videos to explain that because I do not have that set up right now. But anyways, that's good for now. Thanks for watching.